Alright, in this video we are going to be determining the number of different oblique triangles that exist given certain side lengths and angle measures, and we're going to use the law of sines and the law of cosines to solve oblique triangles for all the missing sides and angles. So first, in order to do that, we're going to go over the proof for the law of sines, and as you see here we have a triangle with a height of h, and just to start to prove this, I'm going to get this new equation. We know that sine of angle B equals h over a, because that's the opposite over hypotenuse, and the sine of angle A is h over b. Okay, so then we can use algebra here to move a over to this side and b over to this side, so it'd be a sine b equals h. This is just doing it to isolate h, and then b sine a equals h. And since this equals h and this equals h, we can set those equal to each other. So a sine b equals b sine a. Okay, and now if we subtract both sides by, or not subtract, multiply both sides by 1 over ab, that's simply going to move b over to this denominator and a over to this denominator. Okay, so we get this equation, sine b over b equals sine a over a. And that's only because if we multiply this side by 1 over ab, the a's are going to cancel out, but the b's going to stay in the denominator, and it's going to be the opposite for over here. The b's cancel out, but the a sticks around. So now we have sine b over b, sine angle b over side b, equals sine angle a over side a. And the same works for angle c and side c, so we can add that in here. So it doesn't matter what sides and angles you have, as long as you have opposite angles from sides, you can use this law of sines to figure out any missing angles or sides. Now for the law of cosine, we have this triangle here with you've got the x distance here and the y distance here, but the triangle, it's got a side of B, A, and C, angle A, and then we create this, we drop a vertical line here to create a right triangle to be able to prove our law of cosine. So with this triangle here, this right triangle, we know that thanks to the Pythagorean Theorem, is x minus b squared plus y squared equals a squared. So we can come down here and we can use these up here of cosine a equals this adjacent x over c, the hypotenuse, and sine a equals y over the hypotenuse. Okay, so we can do the same thing that we did up here of using algebra to move that denominator over to the other side. So c cosine a equals x, and c sine a equals y. And now we can use that in conjunction with this that we found from the Pythagorean Theorem up here to prove the law of cosines. So to start, we'll leave this side is a squared the entire time. Okay, but then up here, we know that x equals c cosine a, so we'll substitute that in, minus b squared, then plus c sine a squared. Okay, we're just substituting for y here, but we got to keep that squared. Okay, and then we have a squared equals, so we'll square each of these, we'll FOIL that out, and that comes out to c squared cosine squared a plus, no, minus 2bc cosine a plus b squared. Okay, and this c sine of a squared is going to become c squared sine squared a. Okay, and now we'll move these around real quick just to be able to see this a little bit easier. So we've still got a squared on this side equals b squared plus c squared times cosine squared a plus c squared sine squared a minus 2bc cosine a. Alright, now we see here that we have a common factor in this portion right here of c squared. So we're gonna factor that out. Equals b squared plus, so we're gonna have c squared times cosine squared a plus sine squared a minus 2bc cosine a. Alright, and now we see that here we have c times cosine squared a plus sine squared a, and we know that this equals 1. And 1 times c squared is just going to give us c squared, so we can just not write that on this next one. We've got b squared plus c squared minus 2bc cosine a, and there is your law of cosines right there.